First of all, I would like to thank the Kokoro Research Center. I'm grateful to the organizer of this symposium, also because this symposium drives me to learn something about symbiosis. I go to the dictionary to check the meaning of this word. And how to connect, actually, I'm going to talk more about, from neuroscience perspective, how to relate out the brain from neuroscience perspective to understand symbiosis. When I learn, like from Wiki, who said that this word kind of created by some people quite a long time ago, simply means, symbiosis means living together of unlike organisms. And there's some features of this symbiosis, like mutualistic and parasitic. When I also use Google Scholar to find some books who talk about the biology symbiosis, and the book, I think, basically talk about the from a biological perspective about how different organisms, like animals and plants and insects, how these can coordinate, live together very well together. And when I search Google's using symbiosis, I found these beautiful, warm, nice photos show how animals of different species, they can live together and help each other. And possibly they mutually understand each other, so that one animal does not eat the other animals, because probably he know that he get help from the bird. In terms of humans and other animals, I think there's also very nice photos illustrate how we human beings live together very well with other animals, and these photos give us very warm feelings. I think it's a very good example of the symbiosis between humans and animals. And this word, actually, when I also check the literatures, symbiosis is also used in psychology to talk about sociology, organization, culture, economics, and man-computer symbiosis. So it's quite interesting. I think we can use this word to talk about the symbiosis of human beings. Even human beings are not like a cow and insects and birds. They're not animals of different species, but people speak different languages. We have different religious beliefs. We live in different regions in the world. How people from different groups can live together very well. What kind of cognitive and neural abilities allow us to do that? I think that's a word we can use to talk about this. And also in terms of to help mutually each other so that all can survive very well, I think we can talk about, in such a situation, if people explore a wide forest, we have to, like one person have to help each other, help the other person, so that all of them can live, can survive very well. And at the organization level, we also, it's quite easy to find such example that like one organization help the others, and there's another example that how people help each other. I also got photos from the social medias who illustrate that when there's an earthquake in China, Japan sends people go to China to help, and also when there's an earthquake in Japan, Chinese government also send Chinese come to help. So this is also, I think, a very good example of symbiosis in terms of people who live at different locations in the world, who speak different languages, how in some situation they help each other. And even think about the global, I think, economy, cooperation. Like one country have created the ideas of iPhones, the other country, like factories, make the ideas and then send the iPhones to another country. So the people around the world can, through such cooperation, we can help each other. And this might be a word we can use to understand symbiosis around the international cooperation, through international cooperation. But the question I think I'm most interested in is why people help each other mutually. And from psychology and neuroscience perspective, how do we understand such nice, warm human behavior? One mental process or ability I think is highly related to this mutual help is empathy. Empathy is a word that psychology used quite often to express the ability that we understand and share each other's emotional state. And this ability exists not only in human beings, but also in animals. If some of you are not from psychology, so let me try to explain this psychological process again, using a very short video to illustrate what is empathy. So if you look at this video, because it works. I think at this moment, what I can say is that you are empathize this person's pain. It's quite a vivid feeling that we understand something happened to that guy and he's painful, but meanwhile, you also have this feeling in yourself, right? So I think this is a very good example to illustrate how we understand and share others' feelings. So here I'll focus on empathy for pain. Particularly, we understand and share others' painful feelings. And in daily life, social media always report such a story. For example, this is a journalist who is working in Syria. This guy tried to help this boy who actually was hurt during the war. But after he realized that, he failed. The boy died. I mean, he could not help the boy. And this guy just kneeled down there and started crying. Why is that? Why he does that? I think empathy might provide a psychological explanation of why we understand and share others' feeling, and that drives us to help others. If we cannot help, we feel distressed. So that's the reason, and the psychological reason, or we can say psychological motivation, make us to help each other. And during the last 10 years, and neuroscientists and psychologists start to understand so what's happening in our brain that make us understand and share others' feeling. And there's basically researchers in this field, they use this technique called functional imaging. One is I'm going to talk about here is the functional MRI, and the other is called EEG activity. So both can recognize the brain activity when subjects lying down on the bed in the side scanner, when they watch, when talk, or listen. And the EEG, compared to the fMRI signal, has high temporal resolution and can tell us when the neural response in the brain responds to others' pain. But the fMRI can tell us where, give us very exact spatial information about where the brain responds to others' pain. So the basic paradigm that's used in this field to identify the neural correlates of empathy for pain is that we can simply show subjects a video clip about a person who is receiving painful stimulation versus a neutral or non-painful stimulation. So, but compare these two conditions, we can identify where in the brain the activity will be increased by looking at others' pain. So basically, so far we have known that there's a neural circuit in the brain we call the pain matrix, which consists of the anterior cingulate or somatosensory cortex, subliminal cortex, and also these anterior insular and the somatosensory cortex. So these areas consist of a neural network we call pain matrix that respond to others' pain. And EEG study also can identify by asking subjects looking at these painful photos or non-painful photos, and while we record an EEG, and we can identify the neural responses that occurs quickly, like after about 150 milliseconds. When we watch a photo, the brain will start to respond to the other's pain. And also when we look at others' pain expression, this empathic responses. So basically, I'll make it simple. whenever there's a new response is differentiated between pain with neutral stimuli, or I'll call that empathy responses. So these empathy responses to others' pain expression also occurs quickly, about 200 milliseconds, over the frontal lobe of the brain. And other studies have shown evidence that the neural responses to others' pain, so marked with red color here, and also the neural response to one's own pain. So this neural activity to others' pain and to one's own pain overlapped in some of the brain areas, like the ACC and the insular. So that gives us explanation why we share others' painful feelings, because both self-pain and other pain will activate the similar neural populations. And also, our recent work showed that it's simply by watching others' pain will drive us to do something. In this study, we simply show subjects a video of others in pain, and then we ask subject to press a button. This action, press a button, can do nothing to help others, but it simply by looking at others' pain, make us to press harder the button. So this can explain why to watch others' pain. When the photographer watched this 3-year-old boy in pain, drive him to do something to help. And also found that this empathy activity in the brain can predict how much we help the other people. This example shows that like the greater empathic activity will make people donate more money to a charity organization. So when we think about these cognitive and neural ability that understand and share others' feelings, and also which drives our helping behavior. So we should feel very good about this, because the evolution, human beings do evolve such ability that make us to help each other mutually. Or that, I'll say, might be the neural basis of the symbiosis, how we survive together. But why do I talk about the obstacles here? Because in daily life, you also quite often watch such situations when the yellow and blue team fight together. Finally, the yellow team won the game, and the yellow guys start to laughing and together, but they totally ignore this blue guy. So who lost the game, who was crying on the ground. So in such a situation, the yellow guy, they don't share the blue guy's painful feeling. Why did that happen? So I think that's the topic I'm going to talk about today. I think the nature of such a situation happened in daily life is that this intergroup relationship, whether I see other people as in-group member or out-group member, so such a relationship strongly modulates our empathic neural responses. That is what I'm going to talk about today. But I focused on the relationship, this intergroup relationship defined by race, because race is a perceptual feature will make us quickly to identify who are of the same race as I am, who are different other races. And also, the other reason that I talk about the race, or I call it racial in-group bias empathy, because there's literatures that have documented quite often that medical doctors actually, they show, there's a lot of evidence showing that medical doctors give less painful treatment to the other race patients. And this is I think most of the literatures report this situation in the US. Like black patients usually receive the less pain treatment in clinical trials compared to white patients. So what would be the neural or cognitive underlines of such a phenomena, what I call the racial bias in pain treatment? So during the last few years, we have done serious experiments trying to understand this phenomena and try also to remove the mechanism underlying this phenomena, and also study how possible can we reduce the racial in-group bias empathy. That might be a solution for at least a way that help us to increase the symbiosis. The first study we published almost 10 years ago that we show both Chinese and Caucasian students in Beijing, asked them to watch such a video that either a Chinese model, if you look at this, a Chinese model receive a painful stimulation, or a Chinese model receive a a non-painful stimulation, like this. And also we show them a white Caucasian model who's receiving painful stimulations, and also who receive a non-painful stimulation. So this is kind of we call 2x2 design. We simply ask each subject, either Chinese students or Caucasian students, to make a judgment whether this model is feeling painful or not. Then we use fMRI to check the brain responses to others' pain. And an interesting finding in this study is that by looking at this activity in this anterior cingulate, that's a part of the pain matrix, the activity in this brain region actually show increased activity to a Caucasian model's pain, but not to a Chinese model pain, but only in Caucasian students. If you look at just on the right side, for Chinese students, their brain activity here show increased activity to Chinese pain, but not to Caucasian pain, model's pain. So that's a typical in-group bias in empathic responses. That is, we show stronger, greater activity to the same race pain compared to other race pain. So this study has been replicated in many other studies. For example, when Chinese students watch these painful neutral faces of Asian or Caucasian models, their brain also show a very clearly evidence for empathic responses to Chinese pain, but not to Caucasians' pain. So this is another example. And also, fMRI studies will show that when looking at the pain and neutral expressions, again, Chinese students show increased activity to Chinese pain, but not to Caucasian pain. So someone may ask, are these phenomena, racial in-group bias, specific to Chinese students or only Caucasian students in Beijing? So luckily, the following work. Okay, well, one more thing I have to mention before I move on. Interesting, in these studies, after this fMRI or EEG study, we ask subjects to report explicitly, so how much painful do you think that the model is feeling? Or how unpleasant yourself are feeling when you watch others' pain. So look at these results. The self-report actually did not show any bias. They report others' pain and one's own unpleasantness equally to same race and other race pain. So this in-group bias actually was clear evidence for the in-group bias in the brain responses to others' pain, but not in the self-report measure of empathy. Seems that our culture has a very strong influences to make people not to report explicitly the bias. Okay, then following our first study, there's also other fMRI and EEG studies showing evidence that this racial in-group bias empathy occurs everywhere in the world. Why I say everywhere? So this is the results from an Italian group who scanned white and black subjects in Italy. And you see all these subjects show this in-group bias, increased empathy responses to same race pain compared to other race pain in the anterior insular. When they look at either black or white hands receiving a painful or non-painful stimulation. So these are results from the black and white subjects in Europe. And also, there's an American group who show evidence that European Americans and African Americans, all of them show enhanced empathy activity over the frontal lobe in response to this situation when either a white or black people suffering there. So they also show this in-group bias. So that's the evidence from people in the North America. And this is another study that's showing the white subjects in Italy. They show this enhanced empathy activity to white models' pain, but not to black models' pain. And this is another study report that the white students in Australia, they show stronger empathic activity in the anterior insular to Caucasian models' pain, but not to Asians' pain. Yeah. And another study showing evidence that white and black subjects in South Africa, they also show this enhanced empathy responses to the same race pain compared to other race pain. So that's what I call this the ubiquitous racial in-group bias empathy. It occurs everywhere. You see, here I show the evidence that The racial in-group bias occurs in Asia, Europe, North America, Africa, and Australia. So all the continents around the world, people there show such in-group bias. Seems that our evolution, this is also a gift from human evolution, possibly. And it's ubiquitous. So that's what I talk about. What is racial in-group bias empathy? In terms of the using this EEG fMRI technique to show the bias in brain responses to same race compared to other race pain. And next, I will talk about a few studies to try to understand why, from either biological, social, cultural, ecological perspective, why human evolved such an in-group bias in empathy. The first study we test that whether or not at some point of neural processing, when we process a same race pain, other race pain, whether the brain will engage similar or different neural populations. You can imagine that these two models. I believe that it's possible that, for example, for Chinese students, usually when doing development, initially, when the students watch others' pain, this pain always occurs in Chinese, in his or her parents. But only later on, when become teenager, watch the movies, Hollywood movies, or watch white movie stars show painful stimulation, then they can have the experience and watch other race pain. So the different time course of experiencing same race and other race pain might result in distinct neural populations in the brain to perceive same race, other race pain. So we test this idea using a biological phenomenon called repetition suppression. That is, if you look at this example, usually the biological finding is that if you watch two faces showing painful expressions, if these two faces engage the same neural populations, when you watch this face with the pain expression one and twice, so the neural response to second phase will decrease because you already watched painful phases before. But this occurs only when these two phases engage the same neural populations. If they engage different neural populations, you will not find such a suppression. So that's the logic of this study. So we show subjects two phases, and the second phase always show pain expression, but the first the face can be either Asian model or Caucasian model with the pain expression. So the logic is that if the pain expression of the two faces will engage different neural populations, the repetition suppression to the second phase will only occur when these two phases engage different neural populations. And we did find evidence that only when subjects watch the first and second phase are the same race when we observe the repetition suppression effect on the neural responses to pain. So this is when we watch Asian face. This is what the Caucasian face. But such a repetition suppression does not occur when they watch, like, for example, a Caucasian face and an Asian target, or Asian face or Caucasian face. So there's no such suppression. So these results was confirmed in both Chinese students and the Caucasian students, indicating that at some point of neural processing, to process Asian face or Caucasian face pain, at least in Chinese brain, they might engage different neural populations. So that supports the distinct population hypothesis. And the second study I'm going to talk about is try to test whether or not this same race, other race pain, to process same race, other race pain, depends on different neurotransmitters. The idea is that if both, for example, for Chinese students, watch Asian models pain or Caucasian models pain, engage the same neurotransmitter, for example, here we test oxytocin. So this oxytocin would increase the empathy responses to both Chinese, Asian, and Caucasian models pain. However, when we test this idea, we record EEG from Chinese subjects when they watch Caucasian Asians pain after they receive oxytocin or placebo intranasally. So that's a very simple technique. We can give subjects oxytocin. And we found evidence that, here's the brain responses, but make it simple. We found evidence that the oxytocin actually only increased the empathy responses to Chinese models pain, but not to Caucasian models pain. See, compared to placebo, this empathy response to Chinese pain was increased by oxytocin compared to placebo. But for Caucasian pain, there's no influence, no effects. So that suggests that possibly in the brain, the oxytocin might be specifically involved in processing same race pain, but not other race pain. So this is the second study suggesting that processing same as other race pain might engage different neurotransmitters. And the third one, we tried to test the association between oxytocin receptor gene and the racial in-group bias in pain, because we already found evidence that oxytocin will influence the same race pain, but not other race pain. So in this study, we scanned two subject groups who carry either G allele or the A allele of this oxytocin receptor gene. Again, we show subjects these videos, painful videos, non-painful videos of Asian models or Caucasian models. And we found that in the fMRI results, we showed these empathy responses in the ACC, in the S2, and insular in all the conditions. But when we check the empathy responses in the ACC carefully, we found that only for the G allele carriers, they showed stronger activity to Asian models pain compared to Caucasian models pain. In other words, these G allele carriers show a bias in the ACC empathy responses to the same race pain, but not for the A allele carriers, so they don't show any bias. However, when we do whole brain analysis, we also found that actually for the A allele carriers, they also show bias. What do I mean bias? So they show a stronger activity to the other race compared to the same race pain, but in a neural structure called the nuclear accumbens. So this area actually shows stronger responses to the other race pain compared to the same race pain. Why is that? Actually, if you know about how the brain functions, we know that this nuclear accumbens actually is a key node of the reward system in the human brain. The reward means that when I'm hungry, I get some food, I feel reward, and this NACC get activated. But these subjects, you see, it might feel quite weird. They actually, when they watch other race pain, possibly they don't show empathy responses, but they might even get some reward activity. That sounds not good. And also we found that the ACC activity actually can predict people's attitude, negative attitude toward other race phase. And also this NACC activity can predict negatively how much they want to help others. So the greater activity in the ACC, the less they want to help other race. So this possibly can explain the functional meaning of the in-group bias in the NACC. So that's the third study. We showed that this racial in-group bias possibly is associated with a specific gene in the human brain. And next one, we examine how the social culture environments, experiences will modulate our in-group bias empathy. So to test this idea that actually the idea is that this in-group bias, in-group favoritism might be stronger in the collectivist culture than in the individualist culture. If that's true, we would predict that for Chinese subjects, if you prime them with interdependent collectivist cultural value, they might show stronger in-group bias. If you're priming them with individualist, independent cultural value, the in-group bias might be decreased. So to test this idea, we scan Chinese subjects when they watch these videos, and we found that after priming collectivism cultural value, subjects show clear evidence for in-group bias, so greater activity to Chinese pain compared to Caucasian pain. But after priming with individualist culture, actually this bias was reduced or even reversed. It showed kind of stronger empathic activity to Caucasian models pain compared to Asian models pain. I don't have a good explanation why that happens. But that's the fact that this cultural priming can modulate racial in-group bias, suggesting that the social cultural experiences or social cultural values will contribute to the in-group bias in empathy. Okay, the last factor that we consider about that might induce this in-group bias is environment. So we can imagine in which situation, in which environment there might be stronger in-group bias, in the good environment or in the harsh, in the bad environment. So we hypothesize that in the bad environments, when people have to really try to fight against out-group members to compete for resources, in such a situation, there might be stronger in-group bias empathy. So to test this idea, we ask subjects, Chinese subject again, watch, okay, the same race, other race, pain or neutral expressions, but meanwhile, they have to hold a cold pad, use their hand, or a warm pad. So we simulate, like we're holding a cold pad, we simulate a bad environment compared to the warm environment. So what we found that these are the brain activity results in response to same race, other race pain when holding cold or warm. To make it clear that what I mean in-group bias in these two conditions, we found that, okay, in the warm condition, actually, they don't show such any bias. But only when they hold the cold pad, they show a stronger activity, empathic activity, to Asian models pain compared to Caucasian models pain. It seems that in such a simple manipulation in the laboratory to simulate a bad, harsh environment can increase subjects' in-group bias in empathic neuroresponses. And the second study, we test this idea that the harsh environment can increase in-group bias, is that we simply remind subjects of their mortality, remind them you have to die someday. So such a manipulation, I think, might be a good example of the extreme harsh environment, because in such environment, it's really possible to die. So in such we found that in such a manipulation, and we examine both the EEG and fMRI results. Basically, we found that, so after, relative to the control primary condition, when subjects are reminded of like a physical pain, like when you go to see a dentist, how painful you feel. Relative to such a condition, reminding subjects of mortality, imagine what will happen to your body after you die. So after such a priming, this show a much clear evidence for the in-group bias in empathy responses in these brain regions. And these results were also replicated using fMRI. So both EEG and fMRI results indicate that after priming with mortality, subjects show a stronger in-group bias compared to a control priming condition. So far, these are the studies that we examined how this racial in-group bias empathy can be related to the distinct neural mechanisms, can be associated with the genes, and how these social cultural environments, values, and also the ecological environments can influence the in-group bias, contribute to the evolution of human racial in-group bias empathy. And finally, I think I'll mention a few studies that we're trying to actually reduce racial in-group bias. So anyway, even we can acknowledge that, okay, that's the in-group bias, that's the result of human evolution. We just take it from our ancestors, possibly, but still the current culture, I mean, does not encourage, does not allow this racial in-group bias in empathy, right? So we try to figure out, can we develop some methods in either in laboratory or in real life situation, can we reduce racial in-group bias empathy? The first one we try is quite simple. We simply, actually, I called cognitive intervention. We simply ask subjects to pay attention to imagine this each individual person, how painful that person is feeling. So to increase their attention to each individual's pain. Can such a manipulation increase their brain responses to other race pain so that to reduce racial in-group bias? Actually, this is what we found. So you see, after such an instruction to focus others' emotional state, we found that for Chinese students, they show these empathy responses to both Chinese pain and to Caucasian pain. So there's clear evidence that simply ask each subjects to pay attention to other models' pain can increase their responses to others' pain. And the next one, okay, this result was also replicated by the using fMRI study. They show when they focused others' pain, this ACC, SMA activity was increased to others' raised pain. And also we found that when asked subjects to pay attention to others' emotional state, the bilateral temporal parietal junction, those brain areas are involved in taking others' perspective. And these brain areas actually show increased activity, suggesting that such a task demand make people to take others' perspective, and so that increase their empathic responses. So that's the first study we try to manipulate cognitive strategy so as to reduce in-group bias empathy. And next one, we employed a paradigm called group manipulation, or minimal group manipulation. So in this study, we ask subjects come to the lab. You are invited to the lab and involved in a competitive game. You have to choose a blue or green team to be your game. So when subjects choose, for example, choose a blue team, they have to remember all the members of the blue team. They will be their fellow team. And they have to also remember all the faces of the opponent team. So they have to learn this for half an hour, then they have to pass the test so that they can really remember who are the in-group members, who are out-group members, so that, so then after this, we record the EEG activity from subjects while they watch the same fellow team or opponent team with either pain or neutral expressions. So what we found that in this study, okay, for the opponent team, again, these subjects show empathic responses to Asians' pain, Chinese models' pain, but not to Caucasian models' pain. Again, they show in-group bias. But for the in-group member, for the fellow team members, they show these empathy responses to both Asian models' pain and to Caucasian models' pain. So it seems that once they include another race person as their own team, that's a small team for a competitive game, their brain must become more sensitive to the other race pain. Seems that this intergroup relationship can strongly increase their empathic responses to others' pain. Okay, the last study I'm going to mention is that we test whether or not the real-life interracial interactions can also decrease this racial in-group bias empathy. So how do you test this real-life racial interaction? Actually, it's a few years ago when we, during the summertime, when we tested a group of Chinese students who were born or educated in European countries and in the US. So they have a lot of experiences, like much more experiences to interact with other race people compared to Chinese students who live in and grew up in China. And we show these subjects these painful or neutral video of Asian or Caucasian models. We predict that these subjects might not show in-group bias. In other words, they might show equally stronger brain responses to either Asian model or Caucasian model's pain. And luckily, indeed, this is what we found. You see, in this figure, I show the empathic responses to either Asian model's pain or to Caucasian model's pain. You see, it's quite interesting that these activities to the same race, other race pain, actually overlapped in all these ACC, insular, and somatosensory cortex. And the magnitude of these empathy responses in these brain areas actually are also equal in response to the same race, other race pain. So in other words, these Chinese students, once they leave and grow up in another country, has a lot of much more interracial experiences. They don't show any racial in-group bias empathy responses. So they respond to others' pain equally, regardless the model says the other person are same race or different race people. And moreover, we found that their empathy responses to same race, other race pain actually were positively correlated with each other. So it seems that in terms of both the location in the brain, the magnitude of the brain, and the relationship, these empathy responses to same race, other race pain were quite similar. So these results, I think, suggest that after having these real-life experiences with others people, they might not take other race, each other race people as like agro member, as strongly as people who has a little less interracial experiences, so that they show less in-group bias. Okay, I think that's the all studies I'm going to mention in my talk, and so this part of the results suggests that even though people may argue that okay, this racial in-group bias occurs during evolution, I have no responsibility for that. My ancestors have the responsibility for that, but actually we can do something to change it. It's not inevitable, right? We can do something, either in the laboratory or in the real life situations. Okay, to summarize what these studies suggest. First of all, I think this racial in-group bias in empathetic responses, even though we believe it's not good, but it is ubiquitous. It exists everywhere in the world. And secondly, I think the racial in-group bias in empathetic responses exists in multiple regions of the pain matrix, like in the ACC, anterior cingulate, anterior insular, and somatosensory cortex. So activity in each of these brain corresponds to different process, like a cognitive processing or emotional processing of other people's pain. So this in-group bias actually occurs in each of the key nodes of the pain matrix of the empathic neural circuit. And the third is that racial in-group bias in empathic responses occurs early and quite early in our empathic responses. You see that I show evidence that it may take about 100 milliseconds. The brain will start to show in-group bias in empathic responses. And next one, I think we show evidence that there are multiple reasons, factors that contribute to the racial in-group bias empathy. That's what I mean here. Like they're biological, the social culture, the ecological and environmental influences on the in-group bias in empathy. And the next one, I think it's important to point out that the racial in-group bias empathy responses actually can predict our in-group favoritism in terms of attitude and prosocial behavior. So this new response is not something, the evidence for the racial in-group bias is not something trivial. Actually, it can be strongly associated with our behavior. If we want to try to understand our behavior bias, we have to understand how the brain shows such a bias. And finally, the final point is that we're still human beings. Even though all of us have such a bias, in-group bias, I think human societies still have hope. So we create such a culture, even I think with quite short history, just for like less than 100 years. We create the idea that everyone is equal, we should love everyone, and so these new cultural values may help us to reduce the racial in-group bias empathy. So I'm still optimistic about human beings, even though we show such obstacles. We have this neurocognitive obstacles to human symbiosis, but there is a hope that we can change it. We can reduce the in-group bias by doing something, by creating new cultural values, by giving our next generation more interracial experiences, so increase more international cooperations. I think all these may help us to sometimes will overcome such obstacles. I think the one reason that I'm still I believe this, what I said strongly, because I think the future, imagine the future. Now I'm flying, I was flying from Beijing to Osaka airport in 2.5 hours. So you fly from Santa Barbara to Japan in like 14, 13 hours. Okay, I think people are creating something new, technique, like we might make a faster plane, faster train. So I heard the story that some Chinese think about to create a train that can run faster 4,000 kilometers per hour. If that becomes true, I mean, I'll come to Beijing, from Beijing to Kyoto, maybe in just 10 minutes. This might be one day. I work here at Kyoto University. I live in Beijing. I like to travel community every day. So such a new technique I think, will make the international cooperation much, much easier, much more often. So such experiences, new culture, new technique, we'll make the word smaller. And so that will reduce this group boundary, like you are in group, out group. I think in the future, I think that's the slogan that the Chinese created in 2008 in the Olympic game. Yeah, we try to promote the idea that there's one world, one dream. And this is one day in the future, the whole world become one unit. We have to fight against for the common problem for all human beings. We don't fight against for a problem only for Chinese, for Japanese, for Americans. There might be a problem in the day that is we have to face, all human beings have to face. We have to make a shape to leave the earth to somewhere in the space. In that day, I think we all become one group, one unit. We will be all in-group members. There will be no in-group, out-group members in the future. So that's my dream. It's also a Chinese dream. I hope to become true in the future. Okay, finally, I have to thank all these research was supported by the Chinese funding sources and also my colleagues from Peking University and other universities. And finally, again, I thank you, the organizer from Kokoro Research Center, and thank you very much for your attention. Thanks.